Hi. So this is the second part for central angles, arc length, and arc measure. Today we're going to be doing 7.2b, which is central angles and arc length. What we did before was arc measure. Now we're going to do arc length. The objective is how do you recognize, measure, and solve problems using central angles, major arcs, minor arcs, and semicircles. The objective is the same as we did for 7.2a. Alright, so what is an arc length? So before we need to know what an arc length is, let's do piece by piece in order to get to arc length. So what is the circumference of a circle? It is the length or the distance around the circle. Basically, it's the perimeter. What is the formula used to find the circumference? Either it's 2 pi r or pi d. What is an arc? An arc is a piece of the circumference. So when you see that, when you take a piece, like almost like if you take a pie, a pizza out of a pie, that arc that is created from that slice you take is a piece of that circumference, or the piece of the circumference of the pizza. So what is an arc length? If we know that the arc is a piece of a circumference, the length of that arc, the arc length, is the length of that piece. So how would you find the arc length? We have the formula. Of course, you set up a proportion. It would be the central angle over 360 equals the arc length over the circumference. And based on whether you have the diameter or the radius, it would be either 2 pi r or pi d. And using notations, you have the central angle, theta, that's the notation for angle, over 360 equals L. L represents the arc length, and then C for circumference. So this is the formula, the one in green, that you need to know. Also, you could manipulate the formula and turn it into where you have an arc length equals central angle over 360 times C. And C could be 2 pi r or pi d, depending on what is given to you. So this is the formula in order to find arc length. There is another formula that you might see when you go online, which is S equals the angle times R. That is used if you have a radian as your angle measurement. When we're dealing with the angles here, it's all in degree measurement, not radian. So if you do a problem and you use that formula, S equals the angle times R, you're going to get a wrong answer. So stick to this formula when we're dealing with arc length and they give us a degree, the central angle is in degree form. Alright, so let's do the first example. It says in circle P, PR is 15, so that's in green. Angle QPR is 120, that's in yellow, and they want us to find the length of arc QR. So the piece that I labeled. So PR is our radius, as you can see, because it starts at the center of the circle and goes to a point on the circle. Angle QPR is equal to 120, so that 120 is our central angle. So I labeled it with that notation. And the length of arc PQ will be labeled as labeled as L. So you have those information. Now you can plug it into the formula, which is the angle over 360 equals the arc length over the circumference. Now, basically we just plug in what we need to plug in, the central angle, the circumference. We need to know what the circumference is. What did they give us? They gave us the radius. So what we're going to use? 2 pi r. So then, once you plug in your information, the values in the appropriate spot, you have the circumference 2 pi and r is 15, so you just plug in 15, and then you're solving for L. Of course, you simplify. This will give you 30 pi for the circumference, and then you cross multiply, as you see here, and follow the steps in order to solve for L. So your arc length will be either 10 pi, or if you want to get an approximate value, 31.4. And that's how you use the arc length formula in order to find the arc length. Again, you're not going to use S equals pi r. S equals pi r is if your degree, your central angle, is in radians, not degrees. Big difference. Okay, another example. In circle B, AC is 9, that's the diameter. Angle ABD is 40, that's already marked here. And they want us to find the length of arc AD. So that's the one in green. So again, figure out what is the label for each. AC, I mentioned, was the diameter. The central angle is 40, because the central angle happens where the two radii intersect at the center of the circle, which is the vertex. And the length is L. Using our formula, theta, that's the name of this symbol, theta, which represents angle over 360. 360 represents the circle. Circle has 360 degrees, equals L, the arc length, over C, the circumference. Plug in the information that they gave you. 40 over 360 equals L, we're looking for that, over for our circumference, again, since they gave us diameter, we could use C equals pi D. So then replace the D with 9, and then we cross multiply, and then solve for L, and L comes out to pi, and we all know pi is 3.14. Okay, another example. So for this one, they say the diameter of circle C is 32 units long. Find the length of each of, well, actually the arc that they gave you down in 3. Find the length of the arc formed by the given angle measure. All right, so they have arc HDF. So what I'm going to do is I'm going to highlight that so that way we know what we're using. So arc H, so I'm following the path, H, D, F. So I have to go around there. So this is the arc that we're looking for. And I'm going to put that in another color. Actually, one that I could see. For this one, I'll just put it in black because you won't be able to see the yellow. So that's L. That's the arc length that we're looking for. So starting from this point and ending here. They said that angle HCF is 125. So I'm going to highlight that. So this angle is 125 degrees. Put that in green. 125 degrees. Alright, so we need to find the arc length. So this is what would happen, and I know this might happen to you guys, where you're going to look at the 125 and then plug that in for your central angle. But we're looking for this arc length. So whatever the arc length is, the central angle has to correspond with it. So if we're looking for arc HF, then we would use a central angle 125. But because we're not using that 125, we're using the other angle. So for that one, I'm going to use this. So this angle is what we need to use. So then how do we find that angle? Well, we know that the circle is 360 degrees. So we're going to subtract 125 from 360, and then we get 235. That is going to be our central angle that corresponds to the arc length that we're looking for. Okay, once we do that, then we plug in our information. We use the formula theta over 360 equals L over C. Then we plug in our information. So our central angle is 235 over 360 equals L. That's what we're looking for. Over, since we have the diameter, which they say is 32, will be pi 32. And we simplify, and then we solve for L, and then we get our value as 65.6. Okay, this question was different from the other two questions that I showed you. Basically, you had to add another step where you had to subtract from 360 to find the central angle for the central angle that corresponds to the arc length that we're looking for. So again, pay attention to what they give you and what they ask you for. So if they ask you to look for arc HF, then you would use 125 because that central angle is corresponding to that arc measure or the arc length. In this one, they wanted us to find HDF, which is the other side of that angle of 125. So we have to subtract 125 from 360 to give us our difference, and then use that in the formula to find out. All right. So we've reached the end of this. This is a very short lesson, but just as a recap, we learned about the arc length. The arc length is a piece of the piece of the circumference that is formed by the central angle. We learned about when we did arc measure, which I should have distinguished. So arc length is the distance between the endpoints along the circle. So that's the length of it. Arc measure is a degree measurement, which is equal to the central angle. So they're two different things. If I say arc measure, you're looking for whatever the central angle is, that will tell you that the arc measure is the same. Arc length, you have to actually use the formula to find what the actual length is. All right, so you learned that it's the circumference is the perimeter. We learn about the circumference is either 2 pi r or pi d. You need to know that because you're going to use that in the formula for arc length. You set up the proportion, which is central angle over 360, which represents the degrees in a circle, equal the arc length over 2 pi r, or if you have, they gave you the diameter, pi d. And then the notation, which you should know, is the theta over 360 equals L over C. Right. And if they give you the central angle and they're asking you for the arc length that is that corresponds with the central angle, then you use that central angle and plug it into the formula. But if they give you an angle that does not relate to the arc length that you need to find, then you have to subtract it from 360 to give you that central angle that corresponds to the arc length that they're asking you to find. Right. So if you have any questions, feel free to email me and I'll give you more examples and help you out. All right, so this ends our lesson, and have a good day.